All right, so I will continue. Yesterday, I mentioned about GCD and LCM. Okay, all right. So we stop at GCD, but I miss one thing on page 47. Okay, actually, there is a name. You see that line, every positive integer can be written uniquely. Okay, it's the fundamental theorem of fundamental. Tadi siapa yang datang awal kelas? Saya tanya okey tak? Macam okey. Gelap. Fundamental theorem of arithmetic. So this fundamental theorem of arithmetic, Shiham, you help me later to add in before that word, every positive integer so must be n bigger than 1, yeah, can be written uniquely. Okay, uniquely as P1 to the K1, P2 to the K2 until PS to the KS. Okay, where P1, P2, oh, I should put less than, right? P1 less than P2 until PS are distinct primes, and Pi divides n for all I until S. For each of these Pi, I from 1 to S, P1, P2 until PS, it has to divide n. So it's not all primes, whatever prime that divides n. Okay? And, okay, K, I put J, Kj, K sub J, or K sub I, you can use the same I. They are positive integers. You can also write that. This is actually the reason why 1 is not a prime number. Okay. If somebody asks you why 1 is not a prime number, you know the definition of prime number? A number is prime if the only divisors are 1 and itself, right? P is a prime number if the only divisors are 1 and itself. So I can ask you why 1 is not a prime number? Because the divisors of 1 is 1, which is itself. Okay. So the answer to that is not because my teacher said prime numbers start with 2. Okay, jangan salahkan cikgu pula. It's actually because of this fundamental theorem of arithmetic. Why? Let me tell you why. Before that, I give you an example. So, example, let n equals, like say 12. Okay, so you want to write 12 equal, this is called a product of powers of primes. Product of powers of primes. Okay, product of powers of primes. So you want the prime to be from smallest to biggest. So for 12, conteng, eh? The smallest prime you can divide, which is 2, right? And you divide again. Right? So this is 2 squared times 3. And you see, 2 is less than 3. And the power is integer. So K1 is the power of 2. K2 is like this one. Okay? And this fundamental theorem of arithmetic tells us that you can write this uniquely. Okay, uniquely when you put them from lowest to biggest. And you don't have any other choice. So this is 2 times 2 times 3. Okay, that's the only way to write 12. If 1 is a prime number, okay, this is proved by contradiction. So why 1 is not a prime? Okay, 1 is not a prime number because if 1 is a prime number, you will write, if 1 is a prime number, "12" can be written as 1 times 2 squared times 3. 1 squared times 2 squared times 3. 1 like to the 10 times 2 squared times 3. Right? And this is not anymore unique. Right? Because 1 can be 1 times 1. Okay. Thus, it is not unique. Contradiction. So this is proved by contradiction. So it's not unique. So that is why 1 is not a prime number. Thus, right? So you go back to the question, 1 is not a prime number. Okay. If I give you a bigger number, like 100, how do you put 100? Instead of divide 2, 2, that's one way. But I can also give you like 1,000, right? Which is quite big. You don't want to divide 2, divide 2, divide 2. So a quick way is you can write like this. Put separate into big numbers, right? And then you can put like this. I mean, the probably fastest way, instead of doing this many times, you don't want to keep. Okay. Atif. Muhammad Atif. Okay? Yeah, give me the answer. 2 to the
1.
2 to the 1, 2 to the 2, so 2 to the
2, 3.
3. 5 to the 1, 5 to the 2, 5 to the
3. 3.
which is actually 8 times 125, right? 1,000. But there is no other way. Just this. Okay, so there is that. Yesterday, I mentioned about greatest common divisor, right? The largest one, okay. And sometimes, for example, 1.58. Find So this is greatest common divisor. And I go straight to the example, 12 and 30. There are many ways. If you write out first the product of factors, right, you will write 12 is 2 squared times 3, 30 is 2 times 15, 2 times 3 times 5. So how do you find the GCD? Is that greatest common divisor for each. Let me think. Okay. I remember learning this when I was in first year. Dekat sekolah macam lain sikit belajarnya. And then when I take this discrete, I wouldn't say the year, you also lahir. Okay, I remember taking this class during summer in another university, and then I transferred to my university because my university has didn't offer any class during summer at US dulu. So I went to another university and then I transferred. Okay, I remember this is how they teach. Okay, this is how I learned in my high school. Tak tahu you all belajar mungkin dah lain kan? So the big, like yesterday I mentioned, macam ni kan? That's 3, right? And then there's 2, there's 1. Right? So 2 and 3 is 6. So the GCD is 6. Okay, this is the shortest way actually. And then the LCM, what is the smallest number can then divide both? You multiply, right? 6, 12, 60. Right? Because 60, if 30 you cannot divide, but 60 you can divide 5, you can divide 2. All right, so easy, right? This way. Okay. And there's another way that I learned during my discrete class. Saya padam okay. Is that the GCD is by taking each prime to the lower power. Each prime to the lower power. Each divisor. So 2 to the 1, right? 1 and 2. You compare. 3, both 1, so you take the lower one is 1. There is a 5 here, but to the 0, right? So 5 to the 0. So this is 6. Okay, that's the GCD. I don't know. Zara, ada belajar yang ni tak? Have you seen this before? Zara? Dia kata, Proniza ni kata nak panggil nama orang yang tak video on. Tapi video on pun kena panggil kan? Because he just like smiling. Zara pernah nampak tak? Ataupun this is new? Ataupun tak ingat?
Tak ingat.
Melampau tak ingat. You all ni muda lagi berapa tahun. Meninggalkan sekolah. Okay, anyway, this is. Now to find the LCM is take each one yang bigger one, but you have to take all. So you take 2 squared, yeah? 3 to the 1, then you have to take the 5. Take the bigger one for each one. So you get 60. So this is GCD and this is LCM. Okay, saya bagi satu soalan, ya. Okay. Okay, before I give you one question, let me write this. how do you put this in the algorithm? Okay, how do you put this in the algorithm? If this is the GCD, you can write this GCD as how do you write this? Since this is 6, you can write 6 equals something times 12 plus something times 30. Right? So easy, right? This is just negative 24 plus. So with this GCD, you can always write this equation. Okay. If the GCD is 1, we say A and B are relatively prime. Relatively prime. They don't have common factors. Except 1. Because 1 is always a common factor, yeah? Okay. Okay, let me give you one question. Find A common. You help me multiply using calculator. 4 times 27 times 25 times 11. Later on you multiply on this. Okay, so it's quite hard because it's big and you want to keep dividing. This one just now is okay. The one I give is small number, but this one, so you take the smaller one, right? For the GCD, 2 squared, 3, 5 squared. You cannot take 9 and 11 because the other one don't have, right? So the smaller power, yeah? 2 squared, 3, 5 squared, right? Which is equal to, what is that? 12 times 25. Betul tak ni? Right? Because 25 times 4 is 100, times 3 is 300. And what is the LCM? Okay. LCM. Ada siapa yang dah darab belum? Ada tak? If you have, please say the numbers. Please, someone help me multiply. Yes? Jimpa? Although I have called you last time. Semua orang tak ada calculator ke? Volunteer, volunteer. I want to hear your voice. Can you unmute? Ni semua suara tak keluar, kenapa ni?
29,727,000.
Oh, that's a good comment actually. 9 is not a prime number. 9 is not a prime number. So I need to change this to a prime number. Okay? Arif, that's good. Because you need a prime number bigger. Right? Okay, this is still true because there is no 11 and 13. This one is 13. Okay, I don't change this just now. Tadi siapa cakap tak dengar? Who said just now? Alia? Siapa tadi yang bercakap? This is the same number just now.
29,700. 29,700.
Where? Here?
Yes.
29,
700.
700. This one?
39,000.
39.
Yes.
Okay. Now this?
The 9 should be 11, right?
Hmm?
Yeah. Dekat.
Betul, betul. Okay. Answer? Uish, lamanya mendarab. Can somebody read out the number?
3,861,000. 3 millions.
Million.
Yeah.
3 million.
861,000.
Wow. I used to write like this when I was little, but somehow they remove, right, the comma. They put the space. I don't know what happened now. Okay, so you can imagine sometimes we cannot follow we thought is the easiest way, right? But sometimes, how do you get this? By definition, taking the primes. Okay, now we are, okay, there is one more thing. This is very useful. GCD AB times LCM AB is actually equal to A cross B. You can see, right? If you multiply these two, it's like this times this, right? One is bigger one is smaller. So you always take from one side. This and this, right? And then 5, one from here, one from here. And this one, nothing here, okay? So sometimes you can just figure out the LCM by already getting GCD. Like, right, just now, what is it? GCD of 1230, right? GCD 1230 is 6. So LCM 1230 is 12 times 30 over 6. So we get this to be 60, right? So this is another way to find GCD and LCM. I am ready to talk about Euclidean algorithm. Okay. Okay, now we want to find the algorithm to find GCD. That's another one way to find this. M is Q times R plus, oops, N plus R. Okay. This is to find GCD of M and N. Okay. Step 1 is to write M as quotient times N plus remainder. Okay. Step 2, choose M equal N and N is R. So you take this N, bring it here. Okay, bring it here, and R, bring it here. Okay. And then you go until the next step is to repeat step 2 until the last step is when R is 0, GCD MN turns out to be the N. This N. When R is 0, this becomes your GCD. Okay. What you do is you divide, right? So just now, we go to the easy question. GCD of 12 and 30. Okay. So you will put M is bigger than N, right? Because you want to divide. So 30 is what times 12 plus what? So, kita counting. Yeah, this is right. Right? 2, 6. You're looking for Q and R. And then you move the N to be this. So 12 equals, and you move this to be here. And then when you move that, this is 0, right? Then by this one, GCD 1230 is 6. Then again, just now LCM is A times B over GCD. This is division algorithm. Euclidean algorithm. Okay. Sometimes it's long. If the number is small, the GCD is small, this will be long. Let's try another one. Okay. Fine. Fine. GCD of 190 and 34. Okay. So 190 equals what times 34 plus? So you can divide. Okay, you can divide. Just divide in your calculator and take the nombor bulat dia, nombor bulat dia. You divide in calculator and then take the number on the left. So you will see that this is 5. So when you multiply, you get 170. So you get 20, right? Then you take this 34, take this 20. So this is just 1 and 14. Then take 20 and 14. Then get 1 and 6. Then take this 14 and 6. And get 2 and 2. Until you get 6. You get 2, you get 3 plus 0. And so the GCD is 2. Okay. Okay, this is using Euclidean algorithm. If you are asked to find just GCD, you can use any method. But if you are asked to find the Euclidean algorithm, you have to use this. And there are a few other examples in the book. And the next question, sometimes they ask you to write the GCD in terms of the original, right? Because before I said you can write GCD in GCD of AB can be written as M times A plus N times B, right? How do you get that M and N? So you get that from replacing. Okay, go from down here. From here, you can replace the 6. You can replace and get the 6. Then you can replace until you get only 34 and 190. Then you can get is equal to the GCD. So that's going back. Okay, let's try that. Okay, now let me write. Now I want to find M and N. You can write like this. 2 equal what times 190 plus what times my M and N, right? 34. Okay, so we want to find this. Okay, so just now it's easy, right? Just now, my first example is easy. You can just guess. This one, how can you guess? Because it can be positive or negative, right? So you will start from here, right? Because from here, this is actually is the GCD, right? This is actually your GCD. So you start from there. So 2 equal 14 minus 2 times 6. 2 equals 14 minus 2 times 6. Okay. Now, but 6 can be written as this, right? 6 is 20 minus 1 times 14. Okay, so you have 114 here, 314, 214 here, so 314 minus 220. Now you get this in terms of 14 and 20. So you go back up, you go back up. Okay, now we want to replace, yeah? We want to replace going up. That 14 here is 34 minus 20. So 14 is 34 minus 20. And then we have another 20 here. So this is 3 times 34 minus 320, 220, 520. Don't multiply out because we want to find the multiplication. And this, you can find this, right? The 20. Okay, so 34 is okay. And the 20. 20 is 190 minus 534. So you get 2 equal minus 5, 190. 25, 28, right? Plus 28, 34. Minus 5 times 190. And then there's 25 plus 3, 28, 34. So you can now see that this is the question, right? And this is what we have. Then you can compare. So this is -5. This is 28. So imagine if you don't follow this Euclidean algorithm and you have to find this. You cannot do cuba jaya, trial and error. Nanti tak berjaya-jaya. All right, let's 12. Kita start berapa? 11. Okay. 5 minutes before we take 5-minute break. Let me see what else in here. Okay. The one that I mentioned is in the next, in the least common multiple, in which the GCD is the minimum between the two, right? And the LCM is the maximum between the two. To say that I've gone through, yeah? And there's also example 1.66. Okay, GCD times LCM is A times B. I've gone through this, okay. Okay, I want to mention a little bit about combinatorials. You have learned this in probability and statistics, okay? And you'll see that this is not part of the course information, because after this is relation, binary relation. I want to start in relation, but I would advise you to just go through section 1.8, the combinatorials. We have learned this in probability and statistics. It's not part of our syllabus, yeah, but it's good to refresh. Okay. All right. Okay. So we take 5-minute break, and then I will continue with some exercises. Now, Shiham, you were not here before, but number 13 last time, please check, because my print out the truth table, I cannot read. Okay, Shiham, help me with that one. We've done some of the question. Yes. Oh, we haven't started with the set. Okay, with the set, but it's quite straightforward. Okay, I will start with number exercise 39. Right, take a 5-minute break, yeah. My watch now is 48, so we come back 53. Okay, nak pergi toilet ke, nak minum ke, nak cek kuih ke. Alright, 5 minutes. Or in the meantime, I'm here if you have any question. Unmute and say. Okay. Ni, oh. All right. Okay. Any question before I start? Hello, 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 hello. Saya tak nak cakap seorang-seorang. So make sure you are here. Kan ada reaction tu, bolehlah kalau malu sangat ke, tak nak cakap ke, tak nak tunjuk muka ke. You can just press that reaction. Okay ke, tak okay ke. Angkat tangan ke, angkat tangan saya tak nampak kalau masa tengah mengajar ya. Any question? Kalau tak ada question, inilah jempol. At least saya tak bercakap seorang kan. Okay. Mana tadi pergi? Oh, okay. So if you have your notes with you, okay, I'm going to skip the easiest part of just a set, union of set, right? Combined set, intersection of elements in the set. Okay. Okay, let's try. Let's try. Let me see. Let's try number 50. Oh, 50. Okay, 50, yeah, 50. 50, you have, wait, ABC sets, eh? ABC finite sets. ABC number finite sets. A is 6, B is 8, C is 6. Okay, A is 6, B is 8, C is 6. The union is 11. When you add, you get 20, right? But the union is 11, meaning there is intersection. Okay, A intersect B is 3. A intersect C is 2. B intersect C is 5. Okay, fine. Okay. And we know that I mentioned about this in the last recorded class, right? The number of elements in the union is the number of A plus B, but because the intersection you add twice, you have to subtract one time. Okay. So you can just go direct by this. A union B union C is A union B. Let me draw. Maybe it's easier to see. Right? This is the intersection, right? So the A union B is just inside here, right? If you take A and then you take B, meaning you have added the intersection twice. That's why we subtract once to get just one copy of this one, right? Okay, that is how you get this. Now, if you look at the three of those, to make sure I'm visible. Right? You have A, B, C. Okay, you want to see this. The union of that is this plus this plus this. But if you add this, then you add that. You adding this twice. This one you adding this twice. This one you adding this twice. So you have to subtract this twice of this, right? Because you have added 3 times. So the union of this is equal to, can somebody give me the formula? Wanna try? So this is A plus B plus C minus 1 of this minus 1 of this minus 1 of this minus how many? Minus how many of this? 2, right? Because you have added 3 times. You have added this. If this only 2, you have added this twice. Then you add again. This, you add again. So you add. Then plug in, then you get the number of this part. And this is just plugging in. Okay. Now, this is very common question, number 52. Okay, number 52. Let me read that. I had to stop 12:30 for your quiz, right? Okay, number 52. I will go straight away, put in the Venn diagram. I think it's easier to see. Okay. In a survey of 260 college students. Okay, so 260 college students. There's mathematics, there's computer, there's business. Okay, there's mathematics, there's computer, and there's business. Okay. 14 had taken all 3 types. I start from the last because you had to put in that first. 14 had taken all 3 types of courses. 14. Okay, and then 22 had taken computer science and business. computer science and business, 22. So 8 left, right? That's already 14, right? So 22. 26, mathematics and computer science. 26, mathematics and computer science. So 26, 12, right? 28, mathematics and business. 28, mathematics and business. Okay. 28. 58, business. 58, business. So you add 28, 36, 58. Business. 94, computer science. So 94, computer science minus 34, right? Okay, 94, computer science. Last is the first line, 64, mathematics. 64, mathematics. That's already 28, 40, right? Okay, I want to ask you, Zurin, are you here?
Yes.
Okay, Zurin,
Yes.
help me calculate all this and
Yep.
subtract from 260. I want to know how many outside here. That is part A. The question is, how many students take none of these three?
When 106.
Outside here, 106. You know how I can calculate quickly? Computer science are the largest, 94. Computer science are the largest, 94. 94. Right? And then I just add the rest. 24, 14, 22. How do you get that? So 260 minus 154. So this is. All right, that is part A. Of the students surveyed, how many taken only computer science? Only computer science will be 60, right? Okay, you can try number 53 about the games. Okay, and also number 54, subject. Okay, and I think that's that. Right, the rest is just the combinatoric, which is not part of ours. Okay, now I have some time to start with the second chapter, but because we have tests next week, yeah. So I cover a little bit because we do the tests during our class. Okay, any question for chapter 1? Anyone tried any of the exercises and you couldn't do it, or you want to see the solution? Nah? Kalau okay, what do you have to do? Any question? Any problem? If not, I want to see the thumb. Okay, Nuriza, okay. Jimpa. Shakila pakai jersey apa tu? Okay. All right. Now, let me see. Where is it? Oh. Okay. This one, for relation, you have also seen this, but probably not really familiar with. Oh, set theory, you have also this in set theory. Maybe you forget already, right? So chapter 2 is on relation. Oh, finally I can erase. Okay. So the first one is you have to know about the Cartesian product. About the Cartesian product. So if you have A and B, non-empty sets. So they have to be non-empty. Now, the Cartesian product of A and B is defined to be all ordered pairs. Why we say ordered pairs? Because AB is not BA. Okay, they are considered a different one. So this AB has to be A from A and B from B. Unless A is B, then probably you will see similar, right? A and B. Okay, so example. Let A to be, maybe we draw something today. That's a square, that's a triangle. It's a set because it's a collection of, I would say, the shape, right? The shape. Okay. B, maybe B, I go A, B, C. Okay, can you list what is A cross B and what is B cross A? So A cross B, there are 2 elements here and 3 elements here. So there are 6 elements, yeah? There are 6 elements. And the first one has to be from A, the second one has to be from B. So I can go with the square. And then I start with the triangle. And B cross A, you have to start with the letter. So I can start with A. And then I start with B. And I start with C. Okay, clear, right? It's clear. Okay, now senang kan? Right. Okay, so what is the number of elements in the Cartesian product? What is the number of elements in the Cartesian product? Okay, so the number of elements in the Cartesian product is the product of the individual, right? So the number of elements in the direct product for this one is the product of each of the order. And this is why the order of A cross B is 6, because the order of A is B and the order of A is 2, the order of B is 3 in this case. Okay, now once you get to know the Cartesian product of two different sets, it can be the same sets. You can find the relation. Okay, relation, because relation depending on the Cartesian product. And the definition of the relation is that, okay, so I put definition 2. Okay, for relations. A relation X R from a set X to a set Y is a subset of X cross Y. Is a subset of X cross Y. Okay, meaning from this one, you can just take some pairs and it becomes a relation. Okay. Example, yeah? Example. So let R be, let me just take this. Oh, sorry. Oh, okay. And okay, so this is a relation because this is a subset of this whole thing. All right. Sometimes the elements are not finite. It can be infinite. Okay, and you cannot list discretely, discrete one by one, or finitely, right? So sometimes you cannot just put all the elements inside. You dot, dot, dot. Sometimes you do. Okay, so for example, let A be R. A be Z, B is 2Z. Okay, so, and if you are given the relation, that A from A to B, A is related to B by a double, by 2 times. How do you list the elements? Okay, so if you have X and Y is 2X. Okay, this relation is A comma B. Put A or B if B is 3. So this one, you can shorten this and put just A in Z. So if you want to list, it will be 0, 0, 1, 2, 2, 4, 3, 6, and the negative. And if you want to draw this in a line, right, it's not continuous because there are elements of integers. So it's a dot, 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 and cannot stop, right? Because it's infinite, okay? And if you see the relation, you can have many other relation, right? Which is not actually in R. For example, like 1, 1, or 3, 0, or 4, 0, they are not in R, but they are in the direct product. Okay. Okay. Right. Okay, now next one is, how do you write it out? You can write AB is in R. Okay, AB is in R, or you put A R B. There's a typo there. Should be A and B, not XY, because I want to use AB over there in the beginning, unless I change everything to XY. Because before I use A and B. All right. Or 2.2, change everything to XY. That's actually better. The domain is a subset of X. The range is a subset of Y. Okay, this one you have seen before. Yeah, you collect and it becomes the domain and the range. Okay, now you have to know the property of a relation. Property of relation. This is very important. Properties of relations. And this one, I would choose X equals to Y or A equals to B. So it's the same set, right? You can only look at this when A is equal to B, okay? First one is reflexive. Okay. R is reflexive if A are A for all A in A. Or you put AA in R for all A in A. This means every element is related to itself. Okay, every element is related to itself. Okay, now if I give you example, A is 1, 2, 3. Okay, then your R, you know it's contained in this. You know that A cross A has 9 elements, but R can be any of the subset of 9 elements. It can be the whole 9, but it can be less, cannot be empty. Yeah. So for R to be reflexive, you have to have 1, 1, 2, 2, and 3, 3. Among others, I don't know, dot, depends. Okay. But you have to have 1, 1, 2, 2, 3, 3. Because A is 1, 2, 3, and you have to have A, comma A. Right? Okay. Otherwise, if you, okay. Okay, let me see. Okay, let me give another example. Okay. That is the set A, 1, 2, 3, 4. And I give you the R. 1, 1, 1, 2, 1, 3, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Okay. Go to second. Huzaimi? Huzaimi Afiq.
Yes, yes, Prof.
Okay. Okay. Sesasu-sasu lah. Ha? Is this reflexive?
Reflexive.
Is a reflexive. Yes or no? It is reflexive if AA in R for all A in A.
If
A is 1, 2, 3, 4. Okay. Do you see 1, 1 in there? 1, 1 ada tak?
ada, yes.
Okay. 2, 2,
2, yes.
3, 3,
Also, yes.
4, 4.
No.
Okay. So, is it reflexive?
Dapat.
No, because 4, 4 is not
Oh, no.
inside. To be reflexive, A, comma A has to be in R for all A. Faham eh? So, 4 is in here, but 4, 4 is not in here. So, it is not reflexive. Boleh?
Boleh.
Untung tahu kena panggil nama. You will remember this. No, since 4, 4 is not in R. Okay.